Hello, back again with another video. We've got a Pigeonhole Principle style question. 10 points are chosen in a unit square. Unit square, side length 1, easy stuff. Prove that there exist 2 points whose distance is at most root 2 over 3. So let's draw our square. It's 1, 2, 3, 4, 5, 6, 7, 8, 9 across. 9 down, sorry, so that means 9 across. Alright. 10 points are chosen in a unit square. Prove that there exist 2 points whose distance is at most root 2 over 3. Now when dealing with squares, right, where the hell does this root 2 come from? Let me just label the side lengths. Well, root 2 over 3. Root 2, where does that root 2 come from? Now we know, using Pythagoras, that the diagonal of this triangle, let me just do this in red, which I'll do using the pointer. The diagonal here is equal to square root diagonal equals square root 1 squared plus 1 squared. That's just Pythagoras. That means square root 1 plus 1, which is just equal to root 2. So we force the root 2 now. Root 2 over 3 though, how does that come about? So if we actually draw on our diagonal, root 2 over 3 comes about at this point here, this point here, this point there. Now why is this useful? Oh, let's dig deeper into this question. So you know this length here is root 2 over 3. Root 2 over 3. Root 2 over 3. Should be root 2. Now, well, since it's a square, we can have 2 diagonals. We have a diagonal going this way. Again, we'd have root 2 over 3 here. Root 2 over 3. Alright, so we've somehow broken this square down, but not really yet. So let's reread the question one more time to see if we get any more insight into what we need to do. 10 points are chosen in a unit square. 10. Prove that exists 2 points whose distance is at most root 2 over 3. Now, what can we do? Well, again, we know 10 equals 9 plus 1. We know we need to use Pigeonhole because we need to prove there exist 2 points whose distance is at root 2 of 3. So we resort to the Pigeonhole principle from this, and we know the pigeonhole usually involves n plus 1 and n. N is 9 here. So again, how does this help us? We've got a square and we've got the number 9. Well, 9 is indeed a square number. It's a square number because it's 3 times 3. A 3 by 3. Now, how can we link this to our square? Well, 3 by 3, and we've got a third here. I think we're starting to put the puzzle pieces together now. 3 by 3, how does that help us? We've got a third. So we can actually force a 3 by 3 within our square. So we can have 3 rows, dash, and 3 columns, dash, and dash. Nice. Okay, so we've broken our square into 9 smaller squares of side length a third. Let's just write that in, a third there, a third there. And the diagonal of each of these smaller squares is root 2 over 3. Right, we're moving somewhere, lads. Now, 9 boxes, 10 points. Right, this is really easy now. So let's make some green, use some green now. We need to put 10 points into these 9 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And now where do we put the 10th square? Well, we just simply put it in any one of these. Let's say we put it in the middle one. Now the question is asked us to prove there exists 2 points whose distance is as most root 2 of 3. Well, let's zoom into this square with 2 green dots. Alright, let's draw green dots in. This square has side length third, and its diagonal, as we said, is root 2 over 3. Root 2 over 3. And we know the longest length in a square, or the longest line that can be made within a square, is the diagonal. So essentially we can see as the maximum distance apart these two can be is root 2 of 3 within the square. We can have this there, we have this there. So now that we've done that, we can say that there are 2 points within this square where the distance is at most root 2 of 3, which is excellent because that's just our question done. So at first this question looked like, yeah, we weren't going anywhere with this, but put my brain together, notice that there was a root 2 there, 10 there, 10 equals 9 plus 1, 9 is 3 squared, we've got a square, let's use some more squares, pigeonhole principle, finito. Nice work, nice work. Just patting myself on the shoulder. And that's it, mate, that's all. So see you in the next video. Hope you enjoyed this pigeonhole principle idea, and goodbye.